everybody. It's time for science. All right, so we're doing lesson 4.01 on page 9, turning up the heat worksheet. So what I've got here is 3 cups of water, and the first one is cold water, and I'm measuring its temperature, and it's 42 degrees. There's a spot for you to fill that in on the form under the procedure. So 42 degrees on the first cup of water. This is my room temperature water. I know you can't see it, but the thermometer's coming up, and it looks like it's about, well, our room is probably warmer than this, but it looks like it's about 70 degrees. 70 degrees. And now we've got the hot water. This water just got done boiling. You can kind of see little bubbles on it. It's hot for me to touch. I wouldn't want to touch it for too long. And this is going up to, it's going up there pretty far. It's around 160 degrees. So it's cooled down a little bit from boiling, because boiling was 212 degrees Fahrenheit is boiling, but 160 degrees, still very warm. All right, so now the procedure is that I'm going to drop 3 ice cubes into the water at the same time and then record how long each one takes to melt. So filling out your form here, our test variable is the temperature of the water, okay? Cold, room temperature, hot. The outcome variable is going to be how fast the ice cube melts. The control variables are the amount of water, the size of the container, the size of the ice cube. I'm going to try to choose 3 ice cubes that are just about the same size, okay? So I wouldn't choose, you know, a huge one and a small one. So I'll try to choose 3 that are about the same size. Your hypothesis, you can fill it out a number of different ways. If the temperature of the if the temperature of the water an ice cube is placed in is hot, then the ice cube will melt, what do you think, faster or slower? Or you could go the opposite way, and you could say if the temperature of the ice cube the water is placed in is cold, then the ice cube will melt. So you choose whichever way you want to go with your hypothesis. So here we go. I'm starting back at 0 on my timer. Actually, I think I should do a stopwatch. Okay, so I'll set my stopwatch at 0, and I've got 3 about the same size. And here we go. 1, 2, 3, start. So we're looking to see how fast they melt. And you can see that the ice cube is kind of floating in the room temperature. Same thing in the cold, maybe moving around a little bit more. He is bubbling, and he was just turning around in the really hot temperature. And we are at about 30 seconds here. And I'm not stirring or doing anything else, just looking. And oh, that ice cube is getting tiny, tinier and tinier. Tiny, tiny, tiny. Let's decide when it's gone, and it is gone. All right, 49 seconds for the hot temperature water. That's how long it took the ice cube to dissolve, to go away, to change state, to go into a phase state of going from solid to liquid, a physical change. All right, so now we're waiting still for the room temperature and the cold water. You might as well get comfortable. It's going to be a while. Well, can you tell the difference between the size of the cold and the room temperature? Ooh, he just turned over. So I can definitely tell a difference. This one is still quite close to when I popped him in as far as his size. This one is getting quite a bit smaller. And we're at almost 2 minutes. 2 We're getting tinier. This guy's the same. Getting tinier. Getting tinier. He's still there, but he's much tinier. Look at the size difference now. Getting so tiny. And we're going on 2 minutes and 40 seconds. Oh, did a little jump. Lost a little iceberg going into the water. Again, a physical change, a phase change from solid to liquid. He is so tiny. My head hasn't been in the way the whole time. And we are gonna call him gone. 3 minutes, 12 seconds. And we're gonna stop the video and I will report back to you about how long it takes, because it's probably gonna be a long time for this cold one and the ice to melt into the cold water. All right, thanks. I'll report back to you.